At the end of the day, here's what causes adoption. Time. That's it.
This is DevOps Paradox, episode number 184, How to Reduce Cloud Costs Using Tenacity. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, I know you enjoy working with specific cloud providers. You like Google a lot, right?
I love Google. I would marry Google if I could.
Okay, I don't know that I would do that. But have you ever built a project inside of Google? Now, here's the nice thing about Google, right? You have the Google projects, which is really nice when you have to do a cleanup.
Oh, yeah.
AWS, you could learn from that. But even if you're within a project, what happens when you just keep creating and creating and creating?
You get a call from CEO that his credit card maxed out.
Mm-hmm. But what if it's not just you creating it? What if you've allowed everybody to create in that project? What do you think is going to happen?
Then the call comes earlier.
Oh, comes much earlier. But do you think do you think everybody's doing the exact same thing you are, thinking security and all the other things that go along with that?
No, of course not. Of course not. I mean, vast majority of people are not really interested in what Google does or Azure or AWS. They really just want to see their application running. Anything beyond the simplest possible desire to have an application running is not really interesting.
So on today's show, we have Jason Yeager on from Tenacity Cloud. Jason, how are you doing?
Good. How are you?
Good. If you can, real quick, give us just like a 5-cent overview of Tenacity. We'll come back to it in more depth a little bit later on. Tell us how Tenacity could help us with this problem that we were just explaining, to where we've opened up a project for people to go in and start pointing and clicking and ignore the budget thing for a moment. Let's say that's unlimited budget. We know that's not real life. What are the other problems that can happen when you allow people just to go in and start creating?
Well, sprawl, for one. Everybody has a different story, but some stories that we have, like companies have processes, they follow processes, right? Developers follow processes, and sometimes those processes are broken and you keep on repeating certain things. We had a company that had one part of their development lifecycle didn't destroy a particular piece of infrastructure after development was done. And so what the result of that was an additional few $100,000 a year in additional spend. Nobody was doing anything wrong. It was just the way that the process was defined. Everybody was following it. But one of the things that was missing was destroy this thing when I'm done with it. It is interesting. Projects do make it a little easier to kind of keep track of those things when they're difficult in other platforms, right? Because when the customer was first presented with this information, their first reaction was to open up a support ticket and say the data was wrong. And so I went back to the team and I said, can we just verify this with the raw data just to make sure that this is, there's nothing wrong with our systems. And then before we could even check anything, they came back and said, oh my gosh, I didn't even know to look in that particular spot. So being able to contextualize things in different views so you can keep track of development infrastructure that's out there, or keeping track of things that aren't attached to anything, right? Because if they're not attached to anything, you're most likely not using them. So that's one example of a way that Tenacity helps their customers.
It's especially complicated when you're creating things. Maybe, you're advanced, you do infrastructure as code, Terraform, Pulumi, whatever you're using, right? And still, those things that you are creating yourself often create some other things that the tool you're using is completely unaware of. Right? Kubernetes cluster will create external load balancer if you install Ingress. And if you destroy that cluster, you're kind of a person who really thinks keeps things clean, it will still stay there. I mean, I'm using external load balancer as an example, but a bunch of other things, which I blame providers, to be honest.
Well, it would be if they're not incented to ensure that you turn down things that make them money, which is fine, because in exchange you get a platform that allows you to create things and destroy them within, seconds or minutes, depending on what they are. And so really, having something that kind of closes the feedback loop. Code solves a lot of things and it does it really well, but it can automate things that might not be correct. Because we're constantly coming back and fixing these things, right? I mean, it's like, okay, we replicated that thing. Oh, that wasn't right. So now we've got to back that out. And, so it does ensure that things get created in a similar manner every time, but you still need to check for when that similar manner is not correct or where you're missing something in that similar manner. And that's where a tool like Tenacity helps the business ensure that, businesses, groups, developers, whoever consumes the tool, it helps them tie those things back together to ensure that, and then inject those things back into the pipeline that we learn, right? We can then now eliminate them out of there. And so that's one thing that we help our customers do as well.
We were talking about sprawl a little bit earlier. I mean, obviously one of the downsides to sprawl is cost, like hard, max out the credit card. But what are the other problems with sprawl?
I think it's simply described, or this is the best way I've described it. If you're paying for something you're not using, you most likely don't really know you have it, and therefore most likely aren't securing it in a manner that you would like everything else to be secured, right? If I'm paying for something I'm not using, it shouldn't be there, right? So if it's still there and it's running for months, I don't know I have it. So how do you know that thing is secure? And whether it is secure or not, I mean, maybe you could argue that it is, although I would say, how do you know? But then it's still a potential attack vector that doesn't need to be there, that you don't need to secure, that it doesn't make sense to have things left out there for any reason, cost and security alone.
It increases complexity as well, right? Even though you might not care about those things that are just lost in the space over there and stuff like that. Those are still resources that one way or another need to be managed. Even if that means I need to delete them every once in a while, there's still management, right? There's still work of some
still
sort.
Overhead. It could be that somebody goes in and reviews the, invoice and has to sift through a bunch of things and start to ask questions that take hours to figure out what these resources are. You could be wasting other people's time just by having these things out there, right?
But also, how do you, even if it's only a simple action of just deleting them when you realize that, how do you do that? Because if you have 1,000 subnets and only 10 of those, or 15, some small number is used, how do you know which ones those are?
Well, that's a particular difficult problem to solve with subnets in particular, because if we're just talking about a subnet, the first thing that you can check is whether anything has been issued an IP address in said subnet. Is anything responding, right? I mean, there are ways in which you could do it. That one doesn't have that's definitely one of those problems. I bet there's a lot of people that have that problem, but you could check that in a number of different ways. If you just have a bunch of empty subnets out there, those probably don't have as big of an impact as public S3 buckets, which you just Google most of the breaches that have happened to larger companies have been as a result of something like this. It's not the most complex thing that hits them. I think a couple of years ago, Capital One was hit because they had an S3 bucket that was publicly available. That breached millions of records, right? And, even like the Target one from a few years before that, This is like somebody wasn't patching systems, right? These are the things that get us. They're not, they're not the sophisticated hacker on the other end. They're human error at the end of the day, or repeated processes that should be rectified. You're incented to not let an environment get too big because it costs you more money and it increases complexity. And so, I guess we want to be doing things correctly. We don't want to be ignoring the things that people are common to ignore. So I think making sure that we have the systems in place to ensure that resources that are deployed are used, resources that are deployed that are being used are secure, and that I'm operating my environment in the most efficient way, because it saves not just money as far as operating expense, but time, complexity, and all those other things.
So how do you find out that something is not used? Let's say S3 bucket that you mentioned. Is it doesn't receive enough traffic? How do you know that in the first place? That's we talked about subnets. Okay, that's kind of easy. No other process is using, but theoretically, S3 bucket can serve a purpose even alone, right?
That's correct. Yeah, and there are, one is ensuring that if it is something that's publicly available, that it's secure, that it's deployed in the correct manner. A lot of companies just open up S3 buckets to the public and secure them based on bucket policies and things like that. But, there's a correct way to do that, which is fronted by CloudFront. So ensuring every S3 bucket itself should not be publicly available. No S3 bucket should be publicly available. If you want to expose an S3 bucket to the public, you put a CloudFront distribution in front of it. That's an example of one thing. The other thing that we check for, and if you want to talk about whether it's being utilized or not, all of the metrics around the utilization for each individual S3 bucket is data that's at the fingertips. The problem is there's just too much data that's at your fingertips within your cloud environment. Just operating your infrastructure is, just the logs and the data that it can come from that environment is more than most companies have the patience or the time to really sift through. But we can tell you if it's being utilized, because you're billed based on utilization. So, all of that is built directly in there. And so we can tell you, hey, these buckets, they haven't had any traffic to them, or they haven't had anything get, whatever the metric is that you want to measure. We can tell you those things based on the actual usage billing of the bucket. So not only can we tell you whether things are secure or not, we can tell you whether they're being used and whether now can we go delete it for you? No, nor would you want us to, right? There could be a reason why it's never being used, and then that's because I dumped data there 2 years ago and it's got to sit there for 7 years. We might not have that context, but at least you have something that's telling you that these things exist and they might not be being used, and then you can suppress them based on necessity or go rectify them.
It's almost as if something being used or usually directly reflects in the price of that something. So it's almost as if this is too cheap to be useful. It's not expensive, hence you shouldn't be using it.
Right. Yeah, exactly. Or even if it's inexpensive and you're not using it, should it be out there? What does it have in it? What does it contain, right? All those things that we have to worry about from a breach perspective at this point in time, right? Those things are all things that, our customers are, and, everybody who utilizes public cloud should be looking into, right? I mean, this isn't a problem that's specific or unique to a small set of users in the cloud, right? It's even the most sophisticated of companies have problems identifying these things, because the more sophisticated you are, you're typically that sophisticated out of necessity, out of complexity, right? And the more complex, the easier it is for those things to kind of slip through.
We were talking about S3 being public. That's a really bad thing. What are some other basic cloud objects that you see that people tend to do bad things with?
Database instances, publicly available, because it's like a setting. It's a widget. Create this publicly available. And the most common reason for all of these things is to just get around something, right? I can't get this thing working, so I get around it this way, right? And so it's usually innocent in nature, but that's a big one. Publicly available is a big one. Credentials being used in places they shouldn't be being stored and used is another one. That aren't being rotated, that's another one. We find a lot of resources that we identify as being abandoned or underutilized that usually end up being that. And so back to the sprawl thing, it's essentially the same thing. And S3 buckets really don't apply because if you got a bunch of empty S3 buckets, they're not costing you anything, right? So that's more of a security issue than it is a cost issue. But what it happens to affect are usually the biggest cost drivers within cloud environments where you usually have a lot of that sprawl.
How much of that is, I know that there is no simple answer, but how much of that is shadow IT? Things that were not even meant to be created through normal processes, but just through engineers trying to circumvent some administrative obstacle in a company,
Well, nefariously or just
no, kind of
innocently?
Okay. So those sysadmins are just forcing me to open 57 Jira tickets. I'm going to just spin up a cluster myself. And be over with it.
So you wouldn't. So innocent. I mean, not innocently, but not in a way that they have malicious intention. They're trying to get their job done. Right. Okay. That's human nature. I mean, that you just described. Yes, as humans, where we find we're taught like the shortest path between two distances is a straight line, right? And so if we can figure out a way to circumvent a system, especially if we think there's bureaucracy involved, and not to the point where we think it's really going to do damage, but innocently, right? Like, I need to just test this, right? So I'm just going to create this database instance publicly available because it's going to be temporary, and I don't have to worry about routing this through the VPN and getting this ticket open and getting that done. And I'm going to turn it off right afterwards. And I'm going to delete it right afterwards. Get all this done. I have some problems. I start working on it a little bit. I put it down. Okay, I'll fix it tomorrow. I get to tomorrow. Well, okay, it's the next day before I pick it up again. I pick that up. I get it all fixed. Oh, I forgot to delete the database instance after I was done. This is most commonly a scenario that we're experiencing. It's very rarely some person inside the company trying to as a whistleblower or anything like that. It's usually innocent things that are as a result of a process that should probably be in place, but most likely the company has made too cumbersome over time. And so it doesn't really fit, so there's blame on both sides, right? It's not just that person. It's also that this process is most likely a little bit overburdened or overly cumbersome. And so at the end of the day, it's hard. Sometimes the business and IT and engineering and all these have a tough time communicating. And I think, we try to help with those things at Tenacity.
So earlier you mentioned underutilized. I mean, obviously, if something's not being utilized at all, that's one thing. But how do you determine underutilization? What triggers that tripwire?
I don't know the actual specifics that go into the algorithm on what it is, but in general, there are patterns that certain things use, databases, maybe compute instances. Some other things are easier, right? Like S3 buckets are very easy because you get all that usage data. There are a lot of things that are very easy. You get all the usage data, right? The IO, the puts, the gets, the runtime, the thing, right? So a Lambda function is really easy. If it runs, there really isn't much of a context there because lots of Lambda functions just run once a month. And so and if it's sitting there, it's not really doing any harm. And so there are a certain number of things that you really want to detect from an underutilized perspective. And there are certain reasons why. They could be security, they could be cost. S3 bucket, all of the data around whether something's utilized from an S3 perspective is embedded in the utilization and cost reports from that particular service. You have other services like RDS, which include a lot of that data within the usage metrics as well. And then there are some other pieces of infrastructure where become a little bit more difficult to detect, but there's still some things that you can follow. An instance, a compute instance, for example, that might show X percent utilization throughout the month, some very low percentage. So it's not completely not utilized, but it maintains a, 6% CPU utilization across the month. That would be something we would consider underutilized. It may be doing underutilized. It may actually be doing nothing. It also could be that, this thing runs constant all day long, but it's over provisioned to the nth degree because it's only 6% utilized. So maybe we can ratchet back that instance type to align it with something that's one, cheaper, more cost effective, and maybe more aligned with maybe that application has a ton of memory, needs a ton of memory, and I picked a general instance and I can go back and make it a memory optimized instance. So there's a number of different things from an underutilized perspective that you can look at, mostly from a cost perspective, right? I mean, most underutilized has to deal with cost and cost optimization. And in certain cases, maybe it's abandoned, like the EC2 instance, but for the most part, that's cost.
When somebody comes to you and it's like, we want to check out Tenacity, what are they trying to do? What are they trying to figure out? Is it, how can we save money? How can I optimize my platform? How does that work out?
Save money is like a basic tenet, right? I mean, most companies, the problem of wasted spend in the cloud is a problem that gets bigger every year, not smaller. And it grew exponentially during the pandemic. And so, like AWS was, I can't remember, like somewhere around 50 billion in revenue pre-pandemic, and they're going to be maybe close to 70 or 80 billion post-pandemic. So pretty rapid growth in the cloud. And before the pandemic, it was estimated about 30% of all cloud spend is waste. That's a pretty big number when you think about AWS's revenue, right? 30%. I mean, and it's estimated.
If you were to say that on 50, that's $15 billion.
Estimated wasted spend is 30% across the board. This is across the board, 30%. And you still have the biggest driver in cloud spend is still compute instances. It's not anything that you and I and we think of when we think of the cloud functions and all this. It's still like, I think it's like 60+% or, somewhere around there for EC2. So yeah, spend and wasted spend is a big issue. Just give you an example. So a customer that spends about $120,000 a month in cloud spend, not terribly big, not insignificant, right? There's 100 million line rows in a spread, or dozens of millions to 100 million lines of rows in their monthly billing output. It's 15 gig in size of just text data. You can't sift through all of this by yourself. It's impossible. And what usually happens is, well, we got to get it up, go get it up, go get it up, go get it up, and then you leave a bunch of waste behind, or you have things over provisioned, things like that.
I just want to refer to what you said before about 30%. Out of curiosity, are we talking about 30% of people, companies spending more than they should, meaning that not only what they're not using, but also what they're underutilizing? So kind of, if I use 1 out of 10 CPUs in my EC2, does that count in those 30%? Or
in those estimates, yes. It would be not only things that you aren't using, but things that you've over provisioned as well, which is still a big problem also.
Oh yeah, no, it's a massive problem, but I still have impression, I cannot back this with what I'm going to say with data. I still have impression that's improvement to how we were doing business on-prem. I have impression that all the servers were over-provisioned, just in case, over 30%.
You're absolutely right. It's the same problem. It's just now that it's easier to tie what I actually spend to that one thing. Whereas before, I had this bucket and my, like your IT department would come and say, okay, this is our projected growth. We need this much storage measured in petabytes or terabytes. And we need this much CPU measured in gigahertz and cores and number of servers, right? And so it was like nobody could go and do an audit of all these things. Well, now you actually can. And so, yeah, it's the same problem. It's just now we have the data to take action on making sure we don't have those over provisioned things or those things that we're not using, so we can clean those things up. But you're absolutely right. Actually, the same problems that plague IT departments and engineering departments today are the same ones that have plagued them for 20 years. They're just on a different scale today.
I guess that the major difference might be that, with on-prem, you have to buy it, and then you say, hey, I just made a terrible mistake, but hey, it's already there. It's done. Kind of like, it's not going to cost me next month again, right? While with cloud, it's kind of, there is that monthly reminder, I'm guessing, that you're doing something silly, right?
Well, the other thing is, now you're actually, remember, we used to forecast utilization for buying equipment on an annual basis, right? It was impossible to figure out how much you were going to try to project utilization in servers based on sales. It doesn't correlate to one another. And so I do feel like all of these things become easier with all of this data. It's just there's so much data, it's hard to get to the things that really matter. It's hard to pick out the things that really matter, that really help you run more efficiently or optimized in a way. So I think those things that you mentioned, the sins of our past, so to speak, are amplified from a cost perspective when you think about the difference between CapEx and operating expenses, right? So they're amplified, and getting control of those things, especially during a period of economic insecurity, right? Where companies are looking to make sure that, like, if I can save $200,000 a year on my cloud bill, I don't have to let this person go potentially, right? That or these two people go potentially. And so during this period, we've found it, and this is back to that original question to kind of circle back, that a lot of companies are coming to us for those reasons, is they're looking to understand where all their costs are going, right? To being able to show back, charge back, whether that's customers, whether that's business units and things like that. But ultimately what they're, so they're looking for a number of jobs that we solve for them that they need to do on a monthly basis, right? But at a high level, they're coming to help make sure that we save them money, because that's what everybody's looking to do right now. And everybody's looking to do that all the time. But right now, it's just, everybody's a little bit more in tune with it because of where we are.
So with all that in mind, how do we go about provisioning correctly? Is there an easy button that says, okay, here's my current workload, smash the easy button, and then all of a sudden everything's going to be optimized?
I mean, hey, man, we're doing the wrong thing right now if we can solve that problem.
Well, to an effect, that is what Tenacity does, right?
Well,
not to that extreme, but
not to that extreme. I mean, yeah, like if we could if I could wave a magic wand and fix everybody's, IT problems that they have, that would be a very interesting problem that I'm sure people would pay handsomely for. But yeah, I mean, I don't really make this like a super pitchy sort of thing, right? But we help companies identify those things in which they shouldn't be spending money on, that are potential attack vectors from a security perspective, that your compliance team may be wasting time providing evidence for, that they don't need to be doing that, right? So we do those things, and we help our companies save money and make sure that they're operating their environments not only from a cost efficiency standpoint, but from a secure and compliance standpoint as well.
Okay, so you help them with the cloud spend. Can you help them with the human spend? Here's my question. If you see that somebody came to you and you start the analysis and you see that they're not using CloudFormation, Terraform, anything else, You can tell by whatever's going on that people are pointing and clicking. I mean, it seems like at that point, there could be some human costs, I'll call it moved around, if you will, either eliminated or shifted to other better usages.
I agree. I guess that is an interesting problem to take care of. It's not really something I guess we see a good mixture of, but it's usually companies deploying both sorts of things. Let me answer it in a different way, because we do help companies save human time as well. That comes with the problems that we described today that you guys know exist out there, with not only managing where all the costs are going within a cloud environment, being able to attribute them to different areas of the organization, maybe applications and things like that, but also managing commitments to ensure that you're saving as much money or as much as the providers will allow you to save, so they have all these different commitment plans to manage, making sure that you have storage on the correct life cycles, and that they're actually life cycling things out to lower utilized and lower cost storage. These are all things that are very difficult to solve, and companies that are utilizing cloud infrastructure in a significant way have to deploy people time to do, and they just happen to be jobs that people don't like doing. If developers don't want to go figure out how to sift through the cost and usage report, because AWS's cost and usage report is an example, because the only way you can really sift through that is by deploying about 10 different things within AWS to even view it. And so we save people time, human time, and the mundane time that they don't want to spend on ensuring that they have this data at their fingertips. And as far as utilizing code, for example, we do give companies a way to resolve companies that are utilizing Terraform a way to solve those problems inherently within their code base. But it's not really easy for a tool to tell a company, hey, you're pointing and clicking in the console, you should be deploying via code. It's a hard problem to solve because it's such a mind shift. Like I'm not so sure a tool could do that, but maybe there is something out there that helps you with that.
Well, I think it could at least inform people that, hey, we know we can't change your company culture directly, but we're seeing this, and based on everybody else that we see, it's not such a great idea.
Yeah, no, I agree. I completely agree with that. I think it's very, very interesting because we can tell, how these things are created. And so to lead them down the path at more of like a holistic level, as opposed to providing them information on how they can fix this, whether it's in the console or resolve this issue or with Terraform code, but maybe keep track of how much of their infrastructure, like we have this data, but I'm not sure we keep track of it yet. How much of their infrastructure was deployed with the console versus Terraform, CLI, or whatever the case may be. That's a really interesting one. I like that.
Because potentially, I think that's where many engineers make a mistake, right? Very often engineers try to convince management to do something like, let's switch from clicking to infrastructure as code because we will do a better job with that, right? And I don't think that resonates enough. You're dealing with money. Kind of like, I don't think that there is a better motivator to do something to change the way how you work than, hey, you just lost $100K. Theoretically, right? I'm not saying it's easy. I'm not saying that you can do it, right? But we don't use money as a sufficient motivator often.
Say I'm using AWS, right? CloudFormation is free. Like, I mean, what more motivator do you need to use a tool like? I mean, and I'm not saying use CloudFormation. I prefer Terraform, to be honest. But they're this is my like a company that won't a company or a mindset internally that won't utilize a free tool that is widely known to help standardize configuration at the very least. Like, here's the thing. I usually tell companies, I go, listen, if nothing else, this serves as the record of how it's supposed to be configured. Like, forget automation, forget automating security away, forget automating cost optimization. When I go ask you what this workload is supposed to go, what it's supposed to look like, how it was supposed to be provisioned, this is it right here. it's right there. You can tell me, oh yeah, and you can do all these things. So like at the very least, it's free anyway. But I think if you can regularly tie it back to that problem, then yes. But I gave you an example in the beginning of a company that's they're sophisticated, right? They're larger, they're, revenues in hundreds of millions. And they automated all of this, and it just so happened what they automated didn't include the destruction of one of the pieces. And so when I say it's a mind shift, using code to deploy infrastructure isn't necessarily a silver bullet, because and in fact, automation is the last step in the process of developing, like in manufacturing, right? Automation happens last. You got to work out all the kinks. If you can't deploy a database instance the same way every time in AWS with hand, you can't do it with code.
That's absolutely true.
So that's why I say it's hard for a tool to tell a company that this has to be a mindset change where we're going to develop standardized processes that then get turned into automated code at the end of it. That's why I think it's a hard thing for a tool to solve, but I would love for somebody to solve. It's like if you could solve having a company think differently.
Now starting a new company. This is a startup talk.
Right. This is startup talk now. Right. This is completely different. But if we could solve the problem of getting companies that are laggards or behind the ball to kind of sort of adopt these things, but at the end of the day, here's what causes adoption: time. That's it. It's hard to accelerate it any faster than kind of the adoption curve of everything, right? I think I just read the other day that still only 20% of all workloads live in the cloud. 20%. And so we're talking about wait till it gets to 50 and then maybe you'll get 10% penetration on Terraform or automate or infrastructure tools like that. This is who we are.
You just said the keyword workloads. Very often I see statistics that are very different than what you just said. Like 60%, 80% companies use cloud. 60% or 70% use Kubernetes. But then you ask, okay, yeah, you have a Kubernetes cluster, you're using cloud. What is the percentage of your workload, right? Kind of
workloads.
If you just say, now, today, most of the companies use cloud. Kind of.
Well, they also consider Office 365 cloud.
Exactly.
And I don't consider that cloud. So, right. That's cloud. Yeah. I use Canva. That's cloud. And so, no, compute workloads, 20%. You just think about it. I mean, this is we're at the beginning still we're just now starting to get to the point where people that are ahead of laggards are starting to adopt cloud in a meaningful and significant way. Everybody's had that developer or that test dev account, that S3 bucket that serviced this website, or somebody put their everybody's had one of those for years, right? We're talking about committing to utilizing the cloud and deploying everything there, like companies like Tenacity, who have everything in the cloud, and we wouldn't exist if the cloud didn't exist, right? We're talking about companies like that. We're still a long ways away from that. And so if you think about the problem, not just from a cost perspective, but just from a security and cost perspective in general, 20% of workloads live in there. We've got a long way to go. Everything's going to get more complex, and the providers are not going to be able to help solve the complexity problem. They give you a platform to use. It's not their job necessarily to solve the complexity of how you have it deployed or how much you have. That's on you, and that's where tools like Tenacity and other tools that providers do give you 5 to 10 tools that you can use and put together, and you have to have all this complexity and people managing it, and then it really still doesn't provide you any meaningful data to give to the business. But, you know, also, I always say this, like, do I want my provider managing my discounts for me? Like the company that is charging me, do I want them making sure that I'm getting as much money off as I should be? Probably not, right? I mean, like I always just it's just like there's a really easy way to save like 10 or 15% on your monthly bill within AWS, right? Like it's like a point and click thing. Look at my compute spend, you know, depending on how big your environment is, right? But that's an easy way. And I go, yeah, that's what they tell you. That's the easy thing that they tell you, because by the way, you're happy with that 10 or 15%, but guess what? AWS is happier that that's all you selected, because there's all these other things out there that you can do. And they know that that makes up a majority of where you can save all your money. And AWS blurs the line on security, but it's not usually typically well known where they stop from a security perspective. Whereas I don't know if your audience knows, probably do, but a lot of companies are still confused on where the roles and responsibilities from a security perspective reside in cloud. And I tell everybody, it's more secure. It's way more secure than your internal infrastructure.
Of course.
But it's so much easier to make it insecure than it was before. It's a weird kind of dynamic, right? It's like before you could create any storage bucket you wanted that sat behind a firewall that didn't have any public access, and nobody really knew the difference. You just had a bunch of different folders there. Well, now you every folder you create can be publicly available. It's still more secure than what you had before. It just has the potential to be less secure if you don't have the right processes in place to ensure those things.
Yeah. I mean, simply put, you know, when you adopt cloud, things become more accessible. That makes it insecure, right? Now it's not anymore those 3 guys in a basement having a 3 years queue to do things for everybody else. No, now you can click. You can get it yourself.
Yeah, I'm going to go back to your point before. All cloud does is unmask the sins of the past and things that we've been used to doing forever. You know, like we just start doing them in the cloud. And it's like, wait a minute, that wasn't secure before? Or wait a minute, that costs a lot of money before? I didn't know that just spinning up 10 servers on a, you know, or I didn't know just creating all these things wasn't insecure. So I think it's part of the problem is it is cloud surfaces in all areas, security and all, cost and all of those, some of the sins that we've, you know, kind of been accustomed to just doing in the past.
All of Jason's contact information is going to be down in the show notes. But Jason, if people want to reach out to you directly, what's going to be the best way to do that?
LinkedIn or my email address, jason@tenacitycloud.com. Pretty easy. And LinkedIn is just /Jason Yeager.
Jason, thanks for being with us today.
Thank you.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.